Welcome to this week's episode of the Projector Podcast. I'm Jeremy Glowacki, Editor-in-Chief of Projector Central. Today, Jeff Boccaccio joins us from DPL Labs, the independent test laboratory he founded almost 2 decades ago to test and verify high-speed digital signaling devices such as USB, DisplayPort, HDMI, Lightning, and 1394. DPL Labs facility in Ormond Beach, Florida offers the most precise and critically accurate digital video product performance testing currently offered. Employing an exhaustive multi-element testing regime, DPL Labs puts all manufacturer-submitted products through an electronic torture test. For those products that excel above and beyond the minimum DPL Labs requirements, DPL Labs awards their prestigious DPL Labs 48G certification label. This label assures you of a product that will exceed your expectations in both performance and long-term reliability. In today's conversation, we will explore a little bit more about the history of DPL Labs testing methods, Jeff's personal background, and the evolution of HDMI, specifically what Jeff has uncovered over the past 18 months involving interoperability challenges between projectors, AVRs, video processors, active optical cables, and system accessories such as switches, extenders, and distribution devices. It's a mouthful. We're going to cover a lot, probably not as much as Jeff can do. It would take hours for Jeff to cover everything he knows. But Jeff Boccaccio, welcome to the podcast. It's great to see you.
Thank you so much for inviting me, Jeremy.
How are things in Ormond Beach today?
Oh, it's beautiful weather here in Florida. You know, it's sunny. It's about 75 degrees, and we're in the lab working. So,
Yeah, you wouldn't know what it's like outside and when you're in the lab, right?
Yeah.
So it's great to see you. We crossed paths at CD Expo back in September. You tracked me down, which was really cool because we hadn't talked in a while. And I feel like we have had those kind of meetings quite a bit over the years. I've tried to keep up with all the work that you've done, and probably not covered it as well as I should in the smart home space. But you've always got such great technical details to share, and the challenges of trying to make these products work together when there's HDMI involved in the middle. Before we get into the current state of the technology and some of the challenges you've experienced in the lab, I want to talk a little bit about the background of DPL Labs so people know where you came from, how this came about, and a little bit of your personal background. I kind of quickly learned a few things on another interview you did, and found out that you actually go back to some early engineering in audio, but then you were an audio retailer for many, many years in Boston. Is that correct?
Mm-hmm, that's right.
So you were actually selling receivers and speakers and that sort of stuff, I'm assuming, back in the day.
Yeah. After I got out of school, I started this retail store. Because I was into audio during, paying my way through school. I was working at an audio store, and I just got into it. And I was fortunate enough to become a Macintosh dealer at the time, and that was very prestigious to have. And I was really the only Macintosh dealer in Boston. So it was a lot of work, and a lot to do, but it was very enjoyable. But yeah, that's where I came from, was the audio side mostly.
And then when did it become, when did you end up back into the engineering? Let's backtrack a little bit before. What sorts of engineering were you doing there in the beginning before you became a retailer?
I didn't. I came right out of school, and
okay.
So I didn't work with any other manufacturing firm or company. No.
Okay. So then, what takes you to doing the engineering part of your business? Because that was where you started before DPL Labs started working with HDMI, right? So what was that transition?
Well, my background's engineering, and I've always loved to build products, but primarily I was building them in the audio area.
Okay.
Power amplifiers, preamplifiers, that type of thing.
Okay.
And built them for some companies, freelancing mostly. And then when I got into the store, got to the retail side, that just took up so much of my time. And I did some side jobs while I was in this retail store. People that needed some desperation as far as specialized audio equipment is concerned. And then it just grew out of that. And eventually we started with getting into home theaters like everybody else did, which of course brought in television. And I was and when I was a kid, I was a real TV nut, and so I was always following television at the time, analog television, that is. And then the television, of course, expanded, became hybrid, with some parts being microcontrol based and other parts that were still high voltage transformers, using those old flyback transformers we used to use back then. And so it grew. It grew more and more into understanding where the industry was going in the video side, and then I ended up just relaxing that. Got more and more involved with higher end audio during those years at the retail store, and then eventually I sold the store and started up. Eventually started up Envisions, which is our engineering company, and we started working freelance for quite a few years. And then after that, of course, I was heavily involved with the ATC, the Advanced Television Committee, back when they were still trying to get high definition television off and going. And I'm sure you probably remember the days with the Grand Alliance. I don't know if you were around during that period, but
it was a very confusing time for sure, trying to get it all sorted out.
Yeah, we used to meet down in Washington all the time, with the Consumer Electronics Organization and all the manufacturers. I mean, from Mitsubishi to Sony, everybody was there, and where everybody's arguing, they want this and they want that, and I was part of some of the definitions committees and also the application committees that we started there. So it was interesting to see that, but it was politics. It was like anything else, I can remember the day we went in there and they finally came down and with a heavy fist and they said, okay, this is what we're going to require in high definition television. If you want to say your actual high definition television, you have to have at least 2 speakers for stereo. You have to have a decent amplifier, those types of things. And when we went down there, all of a sudden, all the small guys that made all the tabletop TVs, for kitchens and stuff, they said, well, wait a minute, what about us? We don't have 3 speakers.
Oh,
so
no.
Then they came back and said, well, okay, 1 speaker with an option to go to stereo. It was always something, and we got through it, but we ended up with 18 different formats, and it was a joke. And that's when they finally said, okay, that's it. We're going to throw all these clowns in a room, and everybody comes out with 1 format to get rid of this. That was the Grand Alliance. Yeah. And they did it. They came back with 18 formats. they never did it. So now we've got, all this stuff that we have to do. That's what EDID gets in, right? Yeah. Because we have to do so many things in EDID, and we just stayed with it. And then eventually it transitioned over to digital. And I was part of that because the actual digital interface was 1394.
Okay.
It was not HDMI. It wasn't DisplayPort. It was 1394, and it was a done deal. We were working that for 2 years with 1394, and then out of the blue one day, like overnight, I was contacted. I was at a trade show in Cabo, in fact, and I got this message that they decided to go with the DVI. And I said, what are they talking about? I mean, that wasn't even in the plan, because in 1394, it was multifaceted. It was long distances. It had everything. It really did. And they just pulled the cork. And overnight, they went to DVI. And that limited us to distance to 2, 3, 4 meters with this big Mangunji cable and this big connector. And it was, you had to deal with it, and we did.
Was that some sort of a pressure from the computer side of the business, or what was happening there?
I heard a lot of stories, nothing factual. I heard it was primarily because of maybe the cable companies. Um,
Okay.
they were more. They wanted to have really good content protection.
Okay.
And we had content protection under 1394 called 5C. It wasn't the greatest in the world, but it was content protection.
Yeah.
And then, of course, now with HDCP, it's extremely complicated, very deep,
Mhm.
and still has its issues. So, yeah. So then we just continued on with HDMI when they compartmentalized it into a smart connector. That was a smart move. And then from there we grew. From back in the 1080p days. And
Yep.
then as the bandwidth increased, so then we had to increase the testing process.
Before you
So
got into testing, you were doing contract manufacturing, though, trying to develop products in the HDMI space. Was
yeah,
that the first time you were doing that? Was HDMI, or was it
no,
earlier?
no,
Okay.
actually, we were doing engineering work, and we were commissioned by a lot of guys, NAD, Rush Sound, Parasound. I'm sure there's probably others out there. Class A. We were commissioned by those people to build them HDMI, well, actually DVI in that case, and slowly transition to HDMI. And we were building HDMI electronics for these guys. Between switchers and format converters, we did all that here. And then the problems started with the interoperability problems with HDMI, and that's when we started with trying to figure out how to fix that mess. And
Yeah, your clients, I remember you saying that in the field there were problems and interoperability issues, failures, and these products that you had built to spec weren't working because things that they were connecting to, I guess, weren't communicating properly, right? You realize it's more than just what's in between. It's the electronics on either end that can cause the problem.
it's everybody doesn't necessarily play in harmony.
Uh-huh.
And unfortunately, the interface cable, which is what we do, we don't do any electronics testing. We do just the transmission line.
Yeah.
And of course, in the earlier days, they were coming in from China, and they were being thrown against the wall and thrown on a boat and shipped and sold. And we were getting caught because we were making some of these electronics. In Parasite, for instance, perfect example. Remember Richard Schrein, right?
Yeah.
Well, Richard had us build a 5-way switcher for 1.3. It was great. It worked great. I mean, and we knew what we were doing, and we shipped a bunch of those out there. And he called up. He says, "Hey, we're having problems out here." And I said, "What kind of problems?" So he told me the problems, and they sent the units back. We checked them, and they were fine. And then finally, we had to say, "Okay, send more. I need the cables they were using. I want to know about the TV they were using. Give me everything. I got to figure this
Mm-hmm.
out." And we got everything there, and sure enough, it didn't work, or it worked intermittently. And it turned out to be that the cables, even relatively short ones, were not built to a level that would pass the necessary telemetry. And it was the telemetry problem that was the big one. I mean, video was another issue, but telemetry was the big, and still remains the big one to this day. So um, it was nobody wanted to talk to one another, and it's like you got sources like Blu-ray players and media systems, and you got sinks which are displays, and they're almost running like a free for all. It's like they're doing their own thing. And then you find things. When a problem comes up, you order the equipment in, and a lot of guys are really good. They will send us the equipment for nothing, just so we can figure out what the hell went wrong. And we dig in, and sometimes, like I tell you, in the projector side,
Mm-hmm.
we had. We got some expensive projectors in here, Jeremy. Let me tell you,
Sure.
and video processors, and they were having trouble, and we have to go in and figure out why, and we found why. But then you get another projector and it's got a different problem why.
Mm-hmm.
And so you have to then make it so that the interface, which is the cable itself, whether it be short or long or whatever it's going to be, it's got to be able to work with everybody. And that's a tough nut,
Yeah.
because everybody's kind of like doing their own thing. And HDMI does a good job with the spec. Don't get me wrong; they did a great job with the spec. But there's some areas where you can kind of like do something different, and sometimes those areas between just maybe a software issue, but even a physical issue on the actual physical layer with the cable. And I mean, some of these cables are really bad, and I don't know where they come from, but I got to tell you, the manufacturer's not happy when we tell them we can't give them a label, because we can't give them the label because they're so bad. And a lot of the manufacturers who make these products now, they're afraid to lift their skirts. They're afraid that we're going to look inside and find out what's really going on, and we will, and we do. And it's all for the good for the integrator. These. I remember. I was a retailer for a few years. I was in that installation side, and these kids these kids need help as much as they can give them, and
Sure.
some education and good equipment. So that's what we really rely on. We go after the good. There's great products out there, and things happen, and we find them, and then we say, okay, the cable now has to, instead of this number, we need this number in order to say
Mm-hmm.
that cable is going to work with everybody.
Mm-hmm.
And it's a challenge, Jan.
It's interesting that you've got these cabling manufacturers coming in with products to get certified with you that aren't meeting the standard. So it's not like they're not interested in quality, or at least a quality badge, but
Well,
they're just not achieving it somehow
yeah. Well,
because of whatever reason.
that's not exactly true. They may make the standard, but they don't make our standard.
Okay.
Okay, there's a big
Yeah.
difference because of our standard's a little bit. Actually, it's a lot different. It's many, many, many more tests. The whole testing methodology is expanded dramatically to correct the issues that we had and found in all the case studies that we've done over the years.
Yeah, so maybe you can walk through some of the more, I mean, there's a long history, obviously, since 2006 when you started doing this. Can you walk us through some of the discoveries that you've made in those case studies,
Mm.
in more like the recent, not necessarily the last 18 months, because we'll get to that, but like kind of the steps that you've gone through of realizing what these are the things that were missing or need to be addressed.
I mean, there's things that people don't even anticipate. I'll give you one example. We had
Okay.
one that came in, and it was operating intermittently when we put it on live testing. But when we tested it through the electronics and our instrumentation, it seemed to be okay. And so we kept going back and forth with the manufacturer, and the manufacturer got us in touch with the actual cable manufacturer who made the cable. And we ended up getting nowhere with them because it was a Chinese company, and they're usually pretty helpful. And so we ended up just cutting the cable up to try to figure out what happened.
Hmm.
And what happened was, you're going to really be surprised when I tell you this one. What happened was, after 1.4, and we got HEAC in there, but we had Ethernet control. So we got HEAC and we got ARC. Right? We got ARC. This is now EARC is not out yet. It's just ERC and HEAC. Well, the HEAC, what they did is they decided to put it up on the there was one wire free in the interface. It was pin 14, one wire free, but they need two because it's a differential pair. So what they ended up using was hot plug, which is the trigger device that starts the process after the whole unit starts working. So they use these two devices to do that. Well, if you take those two devices, those two wires, and you don't shield them within the cable itself really well against the telemetry channel, which is the DDC channel, it's called. Well, it'll put little spikes. It'll transmit spikes into the DDC line. Now, the DDC line was being affected because it was shutting off HDCP.
Mm,
So, I mean, nobody would figure that out.
that's
Nobody.
crazy.
And we
Wow.
had to literally dissect the cable. We went back to the manufacturer and we told them. And they
Uh-huh.
said, they didn't know. They said, my God, we know we have to shield that. So I think the company had, I don't know, 10,000 cables,
Wow.
and all of them had to be tossed.
Oh my
And,
God.
and the manufacturer in China had to eat it
Yeah.
because they developed things. I mean, that's just one of so many that I could tell you, I could share with you. And like I said earlier, the telemetry channel is probably the worst of all. And it's very vulnerable to atmospheric conditions, to capacitive loading conditions, and these are things that I'm sure the viewers that watch this don't really know that much about. But it's without that channel, nothing happens, and without power, another problem we see a lot is power, and nobody even thinks about the power in the interface. And without the power, that's the lifeblood of the interface. And HDMI didn't make that power very big because they were only trying to satisfy their own needs. They weren't trying to satisfy people that add on extenders and they start pulling power off the bus. And that's suicide when you start doing that. I mean, it's just you can't do that, and everybody does. I mean, almost every fiber optic cable out there that is an AOC cable, which is a cable that has the electronics built into the heads. Well, what runs those electronics? So you got to get some power, and they rob it from the 5.0 supply line that HDMI provides. So some of them are good. They're good. Some of them are horrible. Like in HDMI's world, their limit is about 50 milliamps. That's all they've got. That's not much. And some of these cables are pulling 200, 300. So you do that, and the voltage is going to start dropping. And then they get intermittents, and then the poor installer's got to go back out and they change the cable, and they last for a week, and it does it again, only to find out that it's the same cable. It just, you're right on the edge, depending on what the source manufacturer built. There's a lot of source manufacturers don't necessarily stay with the 50 mil. Some of them do 300. Some of them do 500. And then you get others that do 75. So you don't. The poor integrator doesn't know what to do, and I feel for them. They call, and they're working out there in the field, and they're asking questions. What's going on? What's wrong? And you ask them some troubleshooting techniques, and you can pretty much figure out kind of what's going on. And so that's just another issue, with the interface. So the interface works great as long as you follow all the rules. And some people they just reach that they go to the tip of their nose and they just go to the edge, and that doesn't work for us. I mean, it may work for the HDMI spec because that they pass that standard, but it doesn't work for us. I mean, we tell our members it's going to work when that thing gets out there until we find another one that doesn't
Yeah.
work.
So your best, so the biggest challenge I remember in the early days was obviously the handshake part of it, but the distance was probably the thing that happened most often, right? Just when you add the distance aspect to it, and you would feel like we've gone so many years that they figured it all out, they fixed all this stuff, but the target keeps changing, right? Because you keep improving technology, you keep getting new challenges that develop. So that's where your job just keeps getting harder, or it just keeps growing. You always have something new to explore.
Well, Gives me a job.
It does, absolutely. But would you feel you're do you actually have like a list of your certified products that then an integrator can go and say, these are the cables that I can trust? Is it that simple, or
Yeah,
then you have
yeah.
the electronics that you have to deal with too?
No,
Um,
no. Yeah, they got the electronics to deal with for sure. And I guess one of the things is that if you go to our website, you'll see all the manufacturers that are there, and they've got their models and they're past it and all that kind of stuff. And you got to watch it because some of them maybe made it to 18 gig, for 2.0, Rev 2.0 for 4K, and some of them, didn't make it to 48, so you don't see them listed there at 48. So you have to do a little studying when you read it, but you'll
okay.
get it.
Okay.
And the difference is that when you start changing over from one revision to the next, you're constantly having to reapply a newer standard, and then of course new anomalies come in, and then we've got to figure out those anomalies to figure out a new testing procedure.
Okay.
So yeah, but you're right. Video has always been an issue. But I'll give you an example, and that was in my little slide thing, but I don't even have to show you that now. But I can tell you that during this process of the projectors, um, and it was serious because you're dealing with people that are buying extremely expensive machines.
Yeah.
I mean, $50,000, $100,000 systems like it's nothing, and they don't work. I mean, they're out there, they plug them in, they don't work, or they go down in a week, or they'll go down in a month. And what do they do? How do you fix that? You got to get it in. You got to wait for it to fail, and you got to figure out why. And when you find out what it is, ironically enough, Jeremy, after what we've learned through our time with HDMI, with the projectors, the most the most problems we have with projectors is in the HDCP. It's always with the HDCP. And it isn't necessarily to say that it was the HDCP coding that was wrong, even though sometimes that's kind of funny. But it's sometimes in the integrity of the HDCP interface, which is called DDC. That's the name HDMI gave it, and it's got to carry that thing nice and clean, and sometimes it doesn't, and sometimes it makes it dirtier, especially on some of these long distance AOC applications, these fiber applications for these. So you see, projectors get a little bit of they got a little bit of a deal because if you're going to have a projector, it's not going to be 3 meters away.
Right.
It's going to be 5 or 10 or 15 or 20 meters, and you just can't go that far on wire. Cable's not going to get it for you, so you got to go fiber. And then when you get the fiber in there, and they're building these things with wrong power supplies and not well built, well then you got more issues to deal with. So the number one issue is HDCP. Number one.
And so is HDCP what's failing in, say, a month in these situations like that you just kind of referenced? Is that something that would start off
Yeah.
working okay and then it stops
Yeah.
working? So does it stop working because of the wear and tear of how that is designed, kind of how you're talking about the shielding problem? Like, why would it start working at the beginning and then fail at some point in time, like a month later?
Yeah. No, it's not wearing out. It doesn't wear out. It goes bad because let's say point of installation. Okay, someone goes in, they go into an installation, right, and the thing's working.
Mm-hmm.
So if it's like they show the customer how to use it, and everybody's wonderful and happy, and they leave, and then about a week later, the customer calls up and says, "Gee, the thing just went out, and then it came back, and then it went out, and now it's dead. Must have been lightning. Must have been lightning." And they come up with all the excuses, and what happens is the HTCP, there's nothing wrong with it. It works fine. But in order to move that data from the source to to the screen, you got to run it through that cable, and that cable, that data has got to be not touched, completely clean, and good integrity, and good voltages. I mean, it goes on and on and on, and sometimes these voltage numbers drift. They will drift because of the amount of currents that are developed within those AOCs, and especially if the installer starts adding other things, like, maybe they put a distribution unit in there, and the distribution unit doesn't have a power supply. It's robbing the power off the bus. Well, that's the same power that operates HDCP. So you can't be screwing around with this thing, and that's what we found. And in the last 18 months, I could show you 7 projector systems that failed due to HDCP. And of course, what's the first thing they say, Jeremy? What's the first thing they say when they have a failure? It's the video. It's got to be the video. The video's bad. It's not going to make it. And out of everything you've got, there's basically 3 or 4 things that are there. There's power. There's voltage, right? There's telemetry, which is HDCP and EDID and all that kind of stuff. And then there's the video itself, right? And if you looked at a chart of the things that go wrong, number 1, telemetry. Number 2, power. Number 3, video. Now, out of all that, video is only about 20%.
So but it's the thing. But it's the thing that stops working. So you think it's the video, probably.
Right? But it's going a long way. And these fiber optic products are really good. I mean, God, as long as they're within their specification. They see the buyer, the people that buy these products, they've got to learn what these products are. And the boxes don't tell you anything. They don't tell you how much current it's pulling. They don't tell you. They don't tell you. And even the AVR company that's providing the source for these, they don't tell you how much current they're providing. So the buyer or the installer or whoever it is, they're punting every time they buy something. And then then sometimes they'll come back and say, "Oh, we got it working. We know why it's working. We got it working." And of course, I'm always interested in why, right? They'll come back and say, "Oh, it's because the turn-on sequence is wrong."
Oh my God!
And they believe it. Okay, so you got to turn the processor on first, and then you turn the screen on, and then of course now with these smart remotes, they can make them go on on their own timeline, right? And it's like that has nothing to do with it.
Yeah,
it's strictly a potluck chance. Because when you restart a system, it's just like a computer. When something goes wrong with the computer, what do they say? Reboot it.
Unplug. Yeah, reboot.
Right. Mm-hmm. Unplug it, and that's what they're doing. So they're turning it on, they're turning it back on, and of course they restart it all. And say, "Oh my God, it's working! The customer's happy. I'm going to go now." I wouldn't go just yet.
Right.
It's. I wish I could. I wish I could say it's better than that, but. And it really has improved. Let me look at the good side. Back in the dark days, you remember when we talked about it as being plug and pray?
Yeah.
Remember that? Well, those were the dark days, and today it's. I mean, we still have problems, but at least the majority of the smaller systems that are small, where they're not long distances and all that kind of stuff, they seem to be working pretty well. But we have another one. I'll give you another one. I'll give you a video problem that projectors have. Oh, okay. This is good. You're going to love this one. And it's true. It's true. Turned out that this guy was using a projector, and the source for the projector was sitting right next to it.
Okay.
Now, how often does that happen?
Not very
Almost
often.
Never, right? But I guess the source was some internet-based product, and it could be remote control. It's kind of like smart TVs, They all have their applications built in. And so he had he wanted the best integrity. He wanted the best. So he put the processor or the source product about, right next to it, so he could use a 1 meter cable.
Mm-hmm.
Oh, 1 meter. I mean, that's I mean, everybody passes 1 meter. You got to really make a mistake to do that one, right?
Yeah.
So he goes out and buys this $300 1 meter cable. It looked like a hose. I mean, it was the hose,
Yeah.
and he plugs it in. It didn't work.
Wow. Okay.
And he couldn't figure it out. So he called me up, and he's trying to figure this out. I'm saying, well, in fact, one of those cables was one of our DPL members, and we passed it. Okay.
Okay.
You don't think I was a little bit concerned, right?
Sure. Yeah.
And so now I want to find the bottom of this, Well, it turned out that the cable was too good. And even though the cable should have responded perfectly fine, the projector, okay, had a relatively sensitive input stage. It was you don't see that too often, where you don't need too much signal to make it work. But in HDMI under 2.0, now that's changed under 2.1. But under 2.0, what they do is they said, okay, back in the day when they wanted to use 3 and 4 and 5 meters, and it just wouldn't work well. So what they did is they brought in some help, and they build the help into the TV set. So a TV set has an equalizer that's used, okay, and it's on all the time. And it's hinged low and goes high. So the higher data rates get more EQ that way. And anyway, so they built this thing it's called CTLE is the name of the unit, and it's an equalization system used to help the cables help them work. Well, that works out just great, except for one little problem, and that is that what if the cable guy does such a good job on his cable, and he's using it on one of these projectors that has this equalizer in it, which they all do, because it's got to be an HDMI certified chipset, right? Well, the equalizer takes the output of the source and saturates the crap out of it.
Okay.
Because it's so much gain because it didn't lose anything in the cable. The cable was just too good. So now what do you do? What do you say to the guy? You say to the guy, don't buy a crappy cable. That's what you should do.
Yeah. Yeah.
So what he did while he was there, I said, look, do you happen to have an inexpensive 2 meter floating around or 3 meter? He goes, oh, I didn't bring that in the job site, but let me go. So he went and got one. Of course, it worked perfectly fine. There was nothing wrong with it at all. Well, the reason why is because there was so much loss in that cable, the equalizer in the projector brought it back up. So, okay, so now you got to say, who's at fault? Nobody's at fault. Everybody did their job. So how do we stop that? And this is where, manufacturers, in my opinion, have to start labeling with some numbers, and the guys in the field, they're going to have to do their homework and learn, okay, it's 200 mils here. I've got 300 mils. That's not going to make it. I need an extra 100, on all the stats. They should run a complete specification sheet on exactly what these cables do in the field. And now the integrator can go out there and look them up. We do that for all of our DPL members. See, so if it's a DPL cable, it's covered. But there's billions of them out there that we don't see. And I get rather excited about when I do that, But it's
I guess the ideal situation for integrators is that they get products that they work with on a regular basis. They're able to maybe they go through that trial and error, and then they figure out what works together. But then you have a unique situation with a distance that's different than maybe they've worked with before. Mm-hmm. Obviously, you like maybe test it out at their facility before they go into the home, But be nice if they could do a length of time test just to make sure it's all good before they go out in the field. Ideally, right?
A burn-in period.
Burn-in period would be ideal. Not everybody's got that time.
Yeah, and I can't tell you how many problems we get from people that call up 6 months later, and it's beginning to go intermittent on them. And
That's a long
And
time.
we find some other anomaly that built up, and maybe there's some emissions interference there from a microwave or something. You never know. I mean, it just happens, and the kids out there that are installing these things, you can't expect these guys to walk in this place with $1 million worth of test equipment to make sure the unit's
No,
going to work. So
right.
and so that's really the responsibility of the manufacturer.
Mm.
Who's going to make the most reliable product out there? And there's, like I said, it's really gotten much better than it did back in the dark days. But there's always new products coming, and there's always funny things like this thing with the cable. Who would think? In fact, I had one guy. The guy, he's not a member, but he's a cable manufacturer. I know. He goes, "Well, we're not going to make any more 1 meter cables. They're just no good. We're going to make 2 meter cables, and we're going to make them so that they use a 26 gauge or whatever it's going to be." And I said, "What? What happens if you're in a rack?
Yeah.
I mean, you got to have short ones to make it neat, and
Mm-hmm.
and they can be really skinny when they're short, as long
Mm-hmm.
as they did their homework. We've done that. We've measured skinny ones, and they do. I mean, if they know what they're doing, they do an extremely good job. But geez, it's like, come on. So
Yeah, it sounds like, of course, you've got a lot to keep you busy. You've got this investment in test equipment that all of these products come in to get certified have to go through this process. Um,
yeah,
the the challenges never cease, but it's so frustrating to me that they still exist. That we can't get past having all of these difficulties come up. Things that technology solves, like this is the case where that's not happening. It's actually creating new challenges along the way. What's your latest development in terms of what you're seeing? That folks need to be aware of as the new standards come out.
you're talking about the new 96.
Yes.
That's going to be a fun project because they have to use the same equalization that I told you about earlier.
Okay.
Okay, so there's danger there, but somebody had their listening piece on. Okay, when
Okay.
they did this, because under Rev 2.1, which is under the 48G numbers, and under Rev 2.2, which is the 96 numbers,
Hmm.
the equalization in those are adaptive.
Okay.
All right, now that's a real big deal. So they're not only adaptive per data rate. So in other words, you got to figure it out. Some guy may have an Apple TV that's running at 4K, 18 gigs, and
Hmm.
some guy may have a Kaleidoscape operating at, say, at 40 gigs. All right, so the machines, these machines that are coming out that are rated to be say a 96 machine, which is a 2.2 rating. The 40 gig guys are doing 10 gigs channel. There's 4 channels. Well, under 4K, which is Rev 2.0, they don't use 4 channels. They use only 3. So they robbed the clock channel in that, which was a clock channel, and it was a nice thing to do. It's basically what DisplayPort does, and they run it on the spare channel. So now they get 4 channels, 10 gigs per channel. You get 40 gigs. It's a great idea, but they still need some equalization, some corrective equalization if they go any kind of distance. So okay, that's fine. So on our system here, the system is smart enough where it'll interrogate the channel, and then when it responds with a signal, an I pattern, which is the pattern we use, it comes back and says requires an equalization level of 3. Well, they give us 8 equalization levels all the way to 8. So we have 8 dB, 7 dB, 6 dB, all the way up to 8. So if a cable's really good, it doesn't need that much EQ. So
Hmm.
it'll come up and register as a 3. And then you have another cable come in, and some of our members will do this. They'll say, "I want to see how good my cables can be." So then they'll say, try this cable next. And we try that next cable, and we found out that it works, it passes, but it needs a level 7. Well, that's really great, because that would eliminate the problem with the poor guy in the $300 cable.
Yeah.
It's going to come in with so much output, it's just going to shut it down. And nobody will know.
Yeah.
That's technology. Somebody who is listening,
Yeah.
they just, what they have to do is, and I'll tell you, the biggest thing we found, Jeremy, the biggest thing is power. I mean, HDCP, that's another issue, but
Yeah.
power is, and HDMI came out, let me think now, I think it's over 2 years ago now. And they came out with a new edition called Cable Power. And they brought it on under 2.1. And what they did is they said, we're going to increase the power spec from 50 mils, which is nothing, to 300 mils. Now, okay, now you're talking. Now the kids won't have any trouble with that. I mean, all those AOCs out there and active devices out there, they're all doing pretty damn good, at 300, not at 50, right? So you say, wow, this is a really good idea. 2 years, Jeremy. There's not one manufacturer that is making a cable power machine. Not one. And what it is it's called the Me Too problem. I'm a cable guy, right? And I want to make this new AOC, this new fiber optic cable, and I'm going to use 300 milliamps. So I need 300 milliamps, right? So they go to the supplier to mix it, which is the source, which is AVRs and Blu-ray players and Apple TVs and all of those. Those are the sources, right? And they go to those guys and say, hey, when are you going to come out that 300? And they say, well, we don't see that many cables being made for 300, so we don't see the demand.
Yeah.
Well, that just keeps going back and forth and back and forth. And then the cable guy says, well, screw it. I'm not going to make these cables if they're not going to make it.
Sure.
Put it in, for crying out loud, but.
Yeah, it's the chicken and egg kind of thing, right?
The chicken and egg, yeah, right. It's a chicken and egg. That's right.
Oh, man.
You try to help them out, and we have it. I mean, Jeremy, I could tell you Friday nights. Well, I'll get a call. I'm here late. The call will come in from a guy, and he's doing a sports bar, right? And it's not working, and it's like 8:00. It's not working. And he goes through the whole 9 yards with me, and I figure out what it is. We finally solved the problem. And it was actually a cable box problem. We solved it. But the poor guy was crying.
Yeah.
He said, I got kids to feed. I spent all my money on the gear to put in here so I could make money to feed my kids. I mean, there's all kinds of different people out there.
Yeah.
And you have to feel for these guys.
Mm-hmm.
They're trying to make a living. They working their butts off, and it's.
I can only imagine the stress that comes from these installations on the commercial side that you're talking about, like the sports bars, the academic buildings with multiple, screens in a room or building. All of those distance challenges. That's a whole other level beyond a home theater.
And what's even more interesting than that, now you're going to really be surprised on this one. We just had another one about 3 weeks ago up in Jacksonville, so I drove up there to take a look at the site. And the guy says, the HDMI, I think it must be the cable. The cable's causing the problem. And I said, well, what's the problem? He said, there's no audio. I said, okay, all right, well, okay. You mean like ARC audio? eARC audio or just PCM audio, which was what they send off on the interface, just PCM. And he says, no audio at all. And I said, none? And he said, yeah, no audio at all. I said, okay. Have you tried changing the cable yet? He goes, well, we put another cable on, it does the same thing. I said, okay. So I said, what have you replaced here? Oh, we put a new TV in. We put new cables in. We did this and this. And I said, well, has anybody changed the AVR? Because I think the problem's in the AVR. And it only happens certain times. So it's intermittent. And anyway, the
Mm-hmm.
customers was the you know those customers you go back 3 times to fix them, and by that time they're frustrated and they don't want to
Oh
hear you
yeah.
about it anymore. Well, this guy was on the 7th time, and
Oh boy. Yeah.
the wife was ready to throw him out the door, and anyway, so he ended up telling me that he didn't change the receiver out, and he said, "Why do you think it's a receiver?" I said, "Because you're running the unit now on only FM. There's nothing else connected to it, and it doesn't have any audio. That
Mm-hmm.
has nothing to do with HDMI." So they changed the receiver to another brand. Works fine.
Oh my
So
gosh.
so now you get the guys that are so paranoid that it's
Yeah.
going to be an HTC. Then they start pinning it on HTC on HDMI when it really isn't.
Yeah. Yeah.
So I made the. I mean, he's a good account. I drove up there. It's about an hour and a half away from me, and I just said, "Well, that was a nice drive."
Oh my God.
And I
You
turned
know,
around and drove.
I told I say this with all respect to people with actual PTSD, but it's HDMI PTSD, right?
Yeah,
It's like you really just assume it's going to be that every time, and for good reason. There's been plenty of headaches and hiccups with it, but boy,
there are.
Jeff, I know we're only scratching the surface of all of the things that you're dealing with and
Oh
all
yeah,
the challenges, but I so respect what your company does and that you're there as a resource for integrators and obviously the manufacturers who are going to you for certification.
yeah,
And
yeah,
um,
yeah.
any last words on things that integrators can be kind of looking for just to make their installations more painless, or consumers who are interested in understanding if they're trying to put together a system? Um, I guess it's hard to generalize because there are so many individual situations that come up, but any last kind of comments or suggestions that you might want to add?
Well, I will. I'll come up with one little fix it that comes up a lot,
Okay.
and it's kind of interesting, and that is that if you got a system, a small system, and you've got maybe 3 or 4 inputs, maybe you've got an Apple TV and a Blu-ray player, and whatever it is. Well, what people don't realize is that the interface is operating at super high speed. Okay. So if you have a cable that's right on the edge, and a lot of them can be on the edge, and with equalization, it fixes them up a little bit, but they could be on the edge. But what they don't understand is that the input of the television or the input of the AVR, there's each channel. So you got video 1, video 2, video 3, video 4, right? Well, when each HDMI connector gets plugged into the back of those, they're going through their own circuit board traces to get to the part, which is the HDMI receiver. They have to get to it. Well, those parts are small. They're small little packages this big. And when you get a package that small, they have to put little pins on it, right? They put little pins on it to connect it all to. Well, they can't connect it all to the same side. There's too many pins. Now, ideally, you'd want to put them all in boom, 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 all 4 channels coming in from the same side. That way, the level of integrity for each of those channels is almost identical. It's a
Yeah, makes
great
sense.
idea,
Yep.
but they don't make them that way. The chip manufacturers don't make them that way. They put an input on the input on one side, another input on the other side, another input on this side, which means when the HDMI connector, let's say video 1, that connector is used, right? It goes in, gets on the circuit board, and goes and starts going all over the board to get to the part. But when you get to HDMI 2, oh, that's in the middle, so it goes straight up. So what I tell people to do is, know your machines, know what kind of TVs are being used. If you're selling a lot of products, a lot of systems, and you use the same machine, let's say it's an LG or a Samsung or whatever it may be, know the machine, because it's very simple to do a test on their own. They need no test equipment to do this, but they can do a test to find out which one of those 4 have the best integrity. and almost 8 times out of 10, it's input 2
Okay.
or input 3, but never input 1 and never input 4.
Now, what are they seeing as a result of that good integrity?
Oh, it gives them really good integrity for HDCP. It gives them extremely good video integrity, especially as the data rate goes up. Because you have to remember, they're playing not only 1080p and they're playing 4K, but they got 4K with deep color. They've got 4K with 444 numbers on them for color space. I mean, all of those require more data, and it's got to operate on the fly. So you want to make sure that you're giving it the best you can. Just be careful not to use that big $300.
Yeah.
Sometimes that could pinch you.
Yeah, I know that's my takeaway is don't waste your money on the big thick HDMI cable.
Well, that it's in some cases it pays off. There's a lot of cases it pays off, but in some cases it doesn't. And there's a lot of good product out there. A lot of good product that it has a very good chance of doing well if they just fine tuned a few items so that the integrator doesn't get stuck. So it's the integrator has got to be more aware of the products that they're installing, and for sure, trying them before you go to the job site. Good idea. But doesn't mean it's going to be perfect. Never is.
Yeah. And Jeff, it's interesting that you've had folks call you and ask you to help save the day, that aren't even clients. So they're finding you and using you as your resource, like sending out their bat signal, to have you come save the day. Do you welcome this situation, or is it stressful for you? Because I'm trying to decide whether we encourage this or discourage it. Is there a better way to find out answers from these folks?
We encourage it a lot, and the reason why we encourage it is because it usually will bring up a new case study, and a new case study will bring us new testing levels that we need to get. And if we didn't have somebody screaming out there that nothing was wrong, we would never know. And we've been doing these case studies for almost 20 years. I mean, we know how to do this, and it works. I mean, we can prove it. It works. We can really inspect, detect, and reject. When it gets serious.
Other than going onto your website, what is the best way that folks can reach out to you if they are facing a challenge? It's not an emergency, but they want to just figure out what's happening on there.
I would say probably the best thing to do is you could email us. Me personally would be jeff@dpllabs.com. Easy. And then, of course, you can always call us. I mean, we love to take the phone calls. It's 386-615. 2324. You call, and people are finding the number. They're calling, and and especially and if you're in a situation where you just don't know where to turn, I mean, we never hang up on you, never. We are, and many times we end up being real good friends over time, and it's a very rewarding job experience for us. Very rewarding, because, most of the companies out there, they really want to do it right. They really do. They just don't know how.
Yeah.
And they rely on Far East products and Far East talents to say, yes, that's good. That's good. I mean, it's okay. And then you look at them, and you have to look at these things before you buy them. And people do. I mean, they buy them and we get them, and oh geez, I didn't know. I already ordered 10,000 units. Well, it happens all the time. That happens all the time. I mean, so what are they going to do with them? They're going to sell them. They're going to dump them. They're going to go somewhere.
Yeah.
So and HDMI tries so hard to get everybody to follow the spec tight, and and they do in some cases, but you get one guy that's off by maybe 8%, and another guy that's off 8% in the other direction. You're going 16% out. Ain't gonna work.
Okay. Yeah.
That's that easy.
Yeah, that makes sense. Well, Jeff, thank you so much for your time today.
Well,
And again, it's a challenging topic to address and to get distilled down to a simple back and forth, because there's just so many things that have happened over the years and so many that remain happening. So
there's always something, and I'm sure. And like I said before, I'm always happy to come on a podcast with you. And we could pick out a particular subject line, and in this case, we're talking about projectors, and the projector guys are beginning to get their act together with with these AOCs and stuff.
yeah.
So yeah, okay.
Well, I appreciate it. Jeff Boccaccio is founder of DPL Labs, and you can learn more about his testing laboratory and find out those phone numbers and everything at dpllabs.com. And that wraps up today's Projector podcast from Projector Central. Please subscribe to the podcast on YouTube, Apple Podcasts, or Spotify. And also check out the latest Projector product news and reviews at projectorcentral.com, where you can also subscribe to receive links to our latest articles on the day that they are posted. For Jeff Boccaccio, I'm Jeremy Glowacki. Thanks for listening.